Chapter 3.2, Synthetic Division. If we're trying to divide two polynomials, and one polynomial is in the form x minus k, in other words, the leading coefficient has to be 1, and it has to be linear, so there can only be a variable term and a constant, then we can do our dividing with a shortcut called synthetic division. Here are your steps to do the synthetic division, and we'll explain them down here. First thing, before I can do the synthetic division, is to make sure that my divisor is in the appropriate form. Notice that I can write this as x minus 2. So it is in the appropriate form, meaning that k is negative 2, right? So if I'm dividing and I see the expression here, I've got to change the sign. If they are giving me k, they've already changed the sign. Next thing I want to do is make sure my exponents go in descending order and there aren't any missing terms. 4, 3, 2, 1, 0, I've got a missing term. So I'm going to come over here and write only the coefficients, not the variables, and I have to fill in that placeholder telling my problem there's a missing term, that constant term. Double checking my exponents, making sure I don't have any missing, and they go from 4 all the way to 0. 4, 3, 2, 1, 0. Okay. Then I'm going to divide by k, which is negative 2. Change the sign when I pull it out. That's why it's negative 2, to put it in the appropriate divisor form. To get me started, I bring the first number down. Then I'm just going to multiply and add in this zigzag fashion. So negative 2 times 1 is negative 2. Add them together. Then go back and multiply. Negative 2 times negative 3, positive 6. Add them together. Negative 2 times 1, negative 2. Add them together. Negative 2 times negative 5, positive 10. Add them together. So here are my new coefficients. I just have to figure out how to put it back in terms of a polynomial. Well, since I was dividing a 4th degree polynomial by a 1st degree polynomial, my resulting polynomial will be 1 degree less. So it's going to start with cubed. So that's the coefficient for my first term, which is an x cubed, minus 3x squared plus 1x minus 5. And this last column is my remainder column. So remainders plus 10 divided by x plus 2. If it didn't go evenly, I have a remainder. So x to the 4th minus x cubed minus 5x squared minus 3x divided by x plus 2 is x cubed minus 3x squared plus x minus 5 plus 10 over x squared. We're going to do synthetic division a lot in the coming days, over and over in multiple problems, so we should get plenty of practice at it. Okay, so now that we know how to do synthetic division, we can discuss the remainder theorem and the factor theorem. I need to know both of these theorems and how to use them for the test. The remainder theorem tells us that if we have a polynomial function that's divided by x minus k, then the remainder, remember we just talked about that last column is the remainder, is equal to f of k. This is really huge for us, particularly since we're not allowed the use of calculators in this course. So remember on the exam, if a problem tells you to use the remainder theorem to find the value of a function, you must use the remainder theorem. You can't just plug the negative 1/2 in. Let's look how much easier that makes our work though. F of negative 1/2, we know what that means. That means replace every x with negative 1/2. But if I just plugged it in, I would have 6 times negative 1/2 cubed is negative 1/8, minus 31 times 1/4, which is negative 1/2 squared, minus 15 times negative 1/2, then I would have to get common denominators, add them together. But our remainder theorem tells me I can do synthetic division. Okay, so first of all, they're giving me the K, right? 3, 2, 1, I'm missing that constant term again. So when I begin working the problem, I have to put in that placeholder, have to tell the problem that there's a constant term missing. Double checking my exponents, 3, 2, 1, 0. And I'm going to divide by negative 1/2. To get me started, bring the first one down, and then multiply and add in this zigzag fashion. So negative 1/2 of 6 is negative 3. Add these together. That's negative 34. Okay, a negative times a negative is positive, so 1/2 of 34 is 17. 17 minus 15 is 2. A negative times a positive is negative. 1/2 of 2 is 1. Add these together, negative 1. This is my remainder. That means f of negative 1/2 equals negative 1. Notice how much easier our math was than trying to plug in f of negative 1/2 and doing this math. It gives me the same thing, but this is a great option, again, particularly when we're not allowed the use of a calculator. Okay, and apparently, if I were to do all that math, I should get negative 1. So that's the remainder theorem. It tells us that the remainder is actually equal to the function evaluated at this K value. The factor theorem tells us that if the remainder is 0, oh, then that means we have found some factors of K. For example, 35 divided by 5 is 7. With a remainder of 0, what that means, if the remainder is 0, is that 7 and 5 are factors of 35. So same thing here. If our remainder is 0, we just found two factors. Here would be a factor, and then our x minus k would be a factor. So let's try to decide whether 2 minus I is a 0 or a factor of f of x. 2, 1, 0. So I don't have any missing terms this time. Okay, 1 minus 4, 5. Double check, 2, 1, 0. And I want to divide by 2 minus I. To get me started, I bring the first number down. Then I multiply. 2 minus I times 1 is 2 minus I. Let me move this over a little bit. Just to give us room. Okay, and remember how I could add this complex number with this real number. I could only add the real number parts, right? That's like negative 4 plus 0i. And I add the real number parts and the imaginary parts, giving me negative 2 minus I. So now I've got to multiply again and put it right here. Well, I may have to come down here and see what 2 minus I times negative 2 minus I is. And I have negative 4 minus 2I plus 2I plus I squared. Oh, but remember, every time we have an I squared is negative 1. So here's minus 2I plus 2I. This is negative 4 plus negative 1 or negative 5. So 2i times negative 2 minus I is negative 5. And I got a 0. If your remainder is 0, then yes, 2 minus I is a 0 of this. Not only that, that means I have found two functions, two factors. The first one being x minus k, right? X minus k, that's one factor. And the other one being this down here. Since it started out a square, this is going to be 1 degree less. So x plus minus 2 minus I. No remainder. So I could write this as x minus 2 plus I and x minus 2 minus I. So you might see where we're going with this. I was able to just factor something that previously I couldn't factor. I was even able to factor it and get complex numbers as part of my factors. So this factor theorem is going to be really important for us, along with the remainder theorem. So using the remainder theorem, that tells me that f of 2 minus I equals 0, right? F of 2 minus I equals 0. The remainder theorem and the factor theorem. Let me know.